You go.
Alrighty, we are on hyperbolas, which is our last conic, and it's on page 1. And we're filling in our definition, and it says a hyperbola is a set of all points in a plane. The difference of whose distances from two distinct fixed points, called the foci, is constant. The constant difference is equal to twice the length of the semi-transverse axis. And again, that would be like 2a. When we talked about ellipses, we related a, b, and c with a formula. We're going to do that here. Our formula is different, as c is equal to the square root of a squared plus b squared. Your difference here is going to be because you're talking a difference here in a hyperbola instead of a sum like we did in the ellipse. Okay? All right, we're looking at that first column there where it says you have a center at 0, 0. Our equation looks like x squared over a squared minus y squared over b squared, and it equals 1. The formula looks identical to an ellipse except for the subtraction sign here. Okay, center at 0, 0. The transverse axis, okay, when we were talking, it's easy for me to refer to the ellipse just because we've done it before, okay? So before, remember that we had A was greater than B, right?
Yes.
So, okay, so my transverse axis here is going to be this x-axis. And it just means my hyperbola is going to open out this way, basically, is what that means. So if my center is here, this would be a vertex, this would be a vertex. Inside those would be your focus, or your foci. Are you kind of with me on that? We're drawing that picture at the bottom, sorry. This is my center, which in this case is at 0, 0. This is a vertex. This is a vertex. The distance from this center to the vertex, this part here, is your distance A. Are you okay with that? So when they're talking about the transverse axis, they're talking from vertex to vertex, which is that 2A up there in that definition. So far, so good? All right. There is a conjugate axis, and that's an interesting way to look at this. Let me give you another distance before I tell you about conjugate axis. The distance from the center to the focus, this distance here from your center all the way out to your focus, is going to be your C. Is that making sense? All right. And so you've got another C from this center out to this focus as well. Now, what they do in order to find these puppies is there's like a little rectangle that's going to be in here, okay? And you can't see them, but there are these things called asymptotes, okay? And they're going to be diagonal ones. And the hyperbola is going to fit right inside those asymptotes. It's going to approach these lines but never actually touch them. That's the pattern that it follows. Okay? Now, this A distance here, or like from here to here, from this center to the vertex, that was my A. That's my semi-transverse, right? So this height of the rectangle, this little part here, is your B, if that's making sense.
Yep.
It's not quite as easy to see as in the ellipse because you're actually inside it. You know what I'm saying? This is, but using the AB this way to draw this rectangle and find your asymptotes helps you to be able to graph your hyperbola correctly. Is that okay?
Yes.
All right. If you look down there, it says that the semi-transverse axis length is A. That's this part here. The semi-conjugate axis length is this B. So the conjugate axis is this whole thing here, which would be 2B. All right. The foci, okay, that's going to be out here. Remember, it was at a distance of C. So this is going to be at C, comma 0, and this other one will be at negative C, comma 0. And the other thing that it has here, it has your vertices at A0 and negative A0. And then it talks about your asymptotes. Y equals plus or minus B over A x. And if you look at that, that totally makes sense. A here is your horizontal distance. B here is your vertical distance. B over A would be my slope. Okay? B over A, the positive one, is the one that goes up. Negative B over A is the one that goes decreasing. All right, so whenever you're talking about hyperbolas, the key features, same type things, your A's, your B's, okay? Whichever one's larger, that's going to tell you which one's your transverse axis. It's also going to let you know which way your well, no, it doesn't tell you which way your hyperbola opens. Your hyperbola opens, I believe, the direction of the one that's positive. Like if X comes first, then it's going to open out that way, the X ways. If the Y is the positive one, it's going to open up and down. If you'll pause that for me.